assignment.
Awesome. Good job.
I'm just that smart.
Some extrinsic motivation is from what I hear.
Nah.
Get your butt in
All
gear.
me.
Get your butt in gear is what I heard. All right, so I'm on page 383, so let's finish this off. This is the last thing that we need to do, okay? Okay, so this last thing that we want to look at, and that finishes off our chapter 11, is binomial expansion. So the reason that binomial expansion is in here is because we want to be able to expand out polynomial expressions without having to do basically all of the work to do it. There should be a quick and easy method to do this. So, for example, x plus y squared. So to expand x plus y squared, that is x squared plus 2xy plus y squared. So basically we FOIL that. Dalen, good morning. Just put your thing on mute for me. Thank you. Okay. So, so x plus y times x plus y, I just simply FOIL it. I get x plus y, x squared plus 2xy plus y squared. Now, can I do this, again, without using any of, like, having to show all of the work to it? And that's what we're learning today. So x plus y cubed. There's a pattern to this, a very simple pattern to this, that's going to allow you to do it without much effort. So it goes x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay, now, with your focus being on the x, notice what happens to the x exponent as we go from term to term. This one I started with x squared, and then I went x, and then x to the 0. X cubed, x squared, x to the 0. And the y started y to the 0, y to the 1, y squared. Y to the 0, y to the 1, y squared, y cubed. Okay, so keeping that in mind, all right, I'm going to just not worry about I won't worry too much about the coefficients. I'm going to explain those in a minute. I want you just to focus on the variables. So x plus y to the 4th, what am I starting with? X to the 4th plus 4 x cubed y plus 6 x squared y squared plus 4 xy cubed plus y to the 4th. So notice what is happening. X to the 4th, x to the 3rd, x squared, x to the 0. Y to the 0, y to the 1, y to the 2, y to the 3, y to the 4. All right? So as for the variables, those will never change. It doesn't matter what I use for them. I always start with the first variable being that exponent right there. And then I work it all the way down. This variable starts as whatever it is to the 0, and then I work its way up, and the last one will be y to the 4th. Another interesting piece of information. On every one of these terms, if you add the exponents together, they will always give you that value right there. So for example, x to the fourth to the fourth. X cubed y, 3 plus 1, 4. X squared y squared, 2 plus 2, 4. X to the 1, y to the 3, 1 and 3, 4. Y to the 4, 4. Okay, now that becomes important for this up here. Yeah, go ahead, Ray.
I got confused. I get what you're saying, but I just don't know where the 6 is coming from.
I haven't got there yet. Let me do one more example, and then I'm going to explain how we get the coefficients, okay?
Okay.
All right, so using that same term, I'm just going to switch this for a second, just to make it look slightly different, but it really isn't any different. Okay, so I have a plus b to the 5th. So a to the 5 plus 5, a to the 4, b to the 1 plus 10, a to the 3, b squared plus 10 again, a squared b cubed plus 5, ab to the 4th plus b to the 5th. Okay, so the variables 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. Okay, so that's just how my variables work. So each term, my first variable is decreasing from that number down, and my second term is increasing to that value up. All right, now Rory asked about the coefficients. Well, there's two things that we need to know about the coefficients. The first is they follow what we call Pascal's triangle. Okay, so I'll show you that in a second. The second is we can get them by following along with this combination of NCK. And that's the next step that I'll get to after. All right. Pascal's triangle works like this. So I start with those two, 1 and 1. And then I go 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Okay, so 1 out here again. 1 plus 4 makes 5. 4 plus 6 makes 10. 6 plus 4 makes 10. 4 plus 1 makes 5. And then a 1. 1, 6, 15, 20, 15, 6, 1. Okay, this is what we refer to as Pascal's triangle. Now, how does this factor into what we just did? Well,
so Mr.
Yeah.
Like this is a lot like apply, right? Like we kind of did.
I don't remember. Did we do this in applied? Let me look.
Yeah.
I feel like we did, and if we did, then I don't have
those squares. Like how many blocks can?
Yeah, I remember this.
No. Oh, what is that, Rory?
My mother.
Like there's like
No, I know what you're saying.
From this place to this place.
Yeah, you're saying.
Like how many combinations is it or something?
Yeah.
We definitely did that.
Yeah, I know what you're saying. You're saying like when we use the grids and we drew the line, the diagonals in, and we added.
Yeah.
It has the same principal effect as it, yes. But this is the reason I'm going to show you this is I want. But this is somewhat different in a sense that the pattern is the same. It's the same idea as that pattern. That is exactly correct. All right. So then the next one would be 1, 7, 21, 35, 35, 21, 7, 1. So it has the same idea as when we were trying to find out how many ways can we go from A to B, going south and west or whatever. So it does have that principle. So x plus y squared, those are going to be my coefficients. 1, 2, 1. X plus y cubed. My coefficients, 1, 3, 3, 1. X plus y to the fourth, 1, 4, 6, 4, 1. X plus y to the fifth, 1, 5, 10, 10, 5, 1. And x plus y to the sixth, same thing. Well, let's just have a look and see what it's going to be hard for you to see that. So there it is. All right, just looking at it. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Okay, so now looking at it, 1 and 4 make 5. That's your second term. So I go 1 on the first one. 1 and 4 make 5. 4 and 6 make 10. 6 and 4 make 10. 4 and 1 make 5. And then 1 on the outside. So you can see that the pattern is exactly the same as Pascal's triangle. That works well for the coefficients. All right. So that's the first thing that we want to know. Okay, is that's how we would expand it. Now this is going to change when my coefficients are not 1 and 1 anymore. That's going to change things. So I'm going to look at, I've already covered the first two examples on page 384. I'm going to look at the working example 2 on page 384. All three of those, I'm going to go through them with you. Okay? So looking at working example 2, I have 3a minus 4b to the fifth. All right. So the first step then is to focus on each individual term, and I'm going to put brackets around everything that I add to this. All right. So not worrying about the coefficients just yet. Not worrying about the coefficients just yet. I'm going to just concern myself with the variables and to the power of 5. So first term being 3a to the fifth plus 3a to the fourth minus 4b to the 1. Again, remember those exponents have to add up to give you that term. Plus 3a to the third minus 4b squared. Plus 3a squared minus 4b cubed. Plus 3a to the 1 minus 4b to the third. Sorry, that's to the fourth. Plus 3a, nope, that's to the 0. And I'm left with minus 4b to the 5. Okay, so that's the first thing that I want to be able to do. This is the first thing. 3a to the fifth, 3a to the fourth, 3a to the third, 3a squared, 3a1, 3a 0. Minus 4b 0, minus 4b 1, minus 4b squared, minus 4b cubed, minus 4b 4, and minus 4b to the fifth. Okay? Speaking of the coefficients, let's just go back one page. So it was x plus y to the fifth, right? So it's 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And again, this is all multiplication right now. All multiplication. All right? So now I've got to simplify this. And like I said, this is a lot of work at the moment. I'm not going to ask you to expand a lot. I'm going to ask you to find a given term, which we're going to use an equation to help us simplify that. But here's how this goes. 3a to the fifth. Of course, I left my calculator. So 3 to the 5th is 243. A to the 5. Okay? Now I have 5 times 3 to the 4 times negative 4. So I have 5 times 3 to the power of 4 times negative 4. So this next term is minus 1620. A to the 4, B to the 1. Now I have 10 times 3 cubed times minus 4 squared. So I have 10 times 9 times 16, 1440. A to the 3rd, B squared. Now here's the first thing I want you to see. All right? When I have a subtract in here, every second term is going to be a negative value. When I looked at this, this was a positive value. This was negative because it was negative 4b to the 1. So that's negative 4. Negative 4 squared is a positive 16. So that becomes plus. Negative 4 cubed, a negative again. So this is going to be a negative. So now I'm taking 10. Oh, I made a mistake right here. Sorry. I think I timed this by 9. This should have been 10 times 27 times 16. 10 times 27 times 16 is 4,320. Now I'm going to subtract. Okay. And I got 10 times 9 times 64. So that's minus 5,760. All right, so this is the part where I'm only really focusing on the coefficients because I know it's a squared b cubed. Down here, it's going to be a plus 5 times 3 times 4 to the 4th. A, B, 4. And then the last thing is 4 to the 5th. Okay, so what I have just done is I've taken 3a minus 4b times 3a minus 4b times 3a minus 4b times 3a minus 4b times 3a minus 4b. 3a minus 4b to the 5th. And I've expanded it out. So that to the 5th ends up being all of this. Okay? First thing I do, expand out all of those terms. So the 3a term and the minus 4b term, using the correct exponents. The first one is a decreasing exponent. The second one's an ascending exponent. All right? And the coefficients follow Pascal's triangle. All right. Questions about that? Questions about that?
So then after we get there, we can just leave it as is, or no?
Yeah, we're done.
Okay.
Okay. Now, like I said, I don't want you to have to expand large ones like this. All right. This is just to show you. What I want you to do now is I'm going to say, all right, I want the 4th term in that binomial expansion. So I want the 4th term in the binomial expansion. Okay? So I'm going to leave this board for a second. I'm going to start the question again, and I'm going to show you where we really need to get to. So I have 3a minus 4b to the 5th, and I want the 4th term. Okay. To get any term value, any value, nth term value, I'm going to use the following to help me do it. Okay. So when we did geometric series and geometric sequences and arithmetic series and arithmetic sequences, we had a way to find the nth term of them. All right. For example, if I wanted to find the nth term of an arithmetic series or sequence, I would go t to the 1 plus n minus 1 times d. If I wanted to find out the geometric one, it was t to the 1 times r n minus 1. So that allowed me to find out the 5th term, the 6th term, the 20th term, whatever it may be. Okay? So that's what I would do. Now, same concept, same principle, using binomial expansion now. So here's what happens. The first thing that you have to recognize, if I'm looking for the 4th term, notice this is tk plus 1. So I let k plus 1 equal 4 to find out what k is. And k is going to be important, and I'll show you why in a second. So I have k plus 1 equals 4. So what does that make the k value then? The k value for this guy is going to be 3. So the k value will be always 1 less than the term value. The k value will be 1 less than the term value. So I'm looking for t to the 4 equals. All right, my n is that 5 right there. So I'm going to go 5c4. Sorry, I already messed this up. My bad. 5c3. nck. 5c3 times my first term, which is 3a, and it's 5 minus 3, which is 2. Then I go times minus 4b, and to the k value, which is 3. All right, so I put the first term in here. I take my n, which is the exponent on the binomial. So 5 subtract k. K is always 1 less than the term. So 3. So 5 subtract 3 is 2. K is 3. 2 and 3 should equal 5 if I've done it right. All right, now I need to find out what 5c3 is. So I go 5 math.
Mr.
Yeah.
Mr. Newton. So when it says x to the power of that thing subtract k, what does that thing
N.
minus
N minus k.
Oh, n. Okay.
Yeah. So it goes like this, Brennan. It goes like this. So x plus y to the n, that's where I get the n from.
Oh, yeah.
That's where I get the n from right there as well. Okay? Good question. All right. So now I have this. So now I need to simplify this whole expression. So 5c3 is 10. 3 squared is 9a squared. And then I have minus 64b cubed. So now I take 90 times 64. I get minus 5,760 a squared b cubed. There is the 4th term of the binomial expansion of this guy. Well, term 1, term 2, term 3, term 4. Did I get exactly what I was looking for? Did I get the same in both? The answer is yes. So I could have expanded it all the way, or I could have done this. All right, so far. So I got the same thing in both. One by using the term, and the second way by expanding it out. I have one more thing to show you that's just general, and that is this. if I have x plus y to the 5th, and I can't remember how Pascal's triangle works, let's say. All right, so I'm not sure how Pascal's triangle works. So how do I get the coefficients for each of these? And it works like this. NC0 x to the 5 plus NC1 x 4 y1. Oh, sorry, I shouldn't be using n's. I should be using 5s. My bad. So I have 5C0, 5C1, 5C2, x cubed, y squared, 5C3, x squared, y cubed, 5C4, x, y to the 4, 5C5, x, that's to the 0, so y to the 5. So the combinations can be used rather than Pascal's triangle at any time to get your coefficient that goes in front. Now, when you expand a binomial expansion, each of these terms has 3 parts to it. And in the 3 parts, all right, you have a coefficient, you have your first term, and you have your second term. And the exponent need to add to give you whatever the term is of the expansion, or the total terms in the expansion. Now, another thing that they like to ask or point out is, how many terms are there in an expansion of x plus y to the 5? Well, 1, 2, 3, 4, 5, 6. There is always one more term in a binomial expansion than what the exponent is here. Okay, so let's look at page 384, example 2b. It asks you for the third term It wants the third term of that binomial expansion. Now, you can expand it out if you like. And really, it wouldn't be that hard to do. Right? You'd expand it out, 5a squared to the 6th, 5a squared to the 5th, 2 to the 1. And you could expand it out to get the third term. I'm going to use the general term to help us here. So the general term, again, works like this. tk plus 1 equals nck times x and minus k y to the k. And again, they give you this. This would be on your formula sheet if you were to write an exam on it. It would be on your formula sheet. So let's go through it. If I've got 6 here and I want the third term, that means that my k value is 2. My k value is 2. It's always 1 less than the term I'm looking for. So I've got 6c2 times 5a squared. All right, 6 subtract 2 is 4. And then I have 2 squared. All right, so again, my n is 6. My k is 1 less than that term, which is 2. Basically, to get this exponent here, I subtract those 2 to get that exponent. I know that that's going to be the same as my k value every time. All right, so I have 6c2, which is, what is that? 6.5 over 4, so I think that's 15. I've got 5 to the 4th. 625, a to the 8 times 2 squared, which is 4. So I'm going to multiply that. So the third term of this sequence 37,500 to the 8. Okay. First of all, to find your, yeah, go ahead.
Do you mind going back just like where's T3 again? If you go back when you have to put in the formula.
Okay, so it asks you for the third term, right?
Yes.
So then that means then I want my third term, this has to be equal to 3. So k plus 1 has to equal 3. That means that my k value is 2.
Okay, yeah.
All right.
Okay,
and then, so then I substitute it in here. So that becomes 2 here. This is 6 subtract 2. That's 6c2.
Okay, yeah. So then, okay, so n subtract 2, so that's 4 there, and then so 2, so that's 4. Okay, yeah.
You good?
Yeah.
Okay. Girls, you okay? Any questions?
I'm good. Yeah, I'm kind of getting it.
Okay. All right. Well, let's do the third one then. Let's do the third one here. So it gives us okay. Now, this one adds a different element to it. So I'm going to show you how to do it. Okay, so for the last 2 questions, it gave me the term value I was looking for. So that way I can jump right into this equation right here, and I can simply find out what I want out of that term value. Okay, that's important. All right, if I know the term, I can just simply use this general term to help me find out what the actual term value is that they're looking for. But in the C part, I don't know the term value, but what I do know is that it wants the coefficient, the variable, to have an exponent of 5 on it. Okay, so here's what I do to make this real quick and real simple, is I write out the first 3 terms of the expression using just variables. I don't care about the numbers, coefficients, nothing. I don't need to worry about it. So that 2, I'm going to ignore for the time being. So the first term of this whole thing is a cubed to the 7. So that gives me a to the 21. The second term of this whole sequence is a cubed to the 6 over 1 over a. Okay, because that's 1 over a to the 1. So 6 times 3 is 18. 18, take away one of those a's, a to the 17. A cubed to the 5th over 1 over a squared. A cubed to the 5th is a to the 15th over a squared. That's a to the 13. Can one of you tell me what you think the next one's going to be? A to the what? Can you tell from, what do you got, Brendan?
8 to the 9.
Okay, that one will be a to the 9, and what's the next one going to be? A to the 5th. So what I do is I find the first 3 terms just so that I can see this pattern. I could do it after the first 2 terms, but if I make an error, I can't see it. But if I do the first 3 terms and this is the same, I'm going back by subtraction the same way, then I know I've probably got it right. Okay? So which term is this then? 1, 2, 3, 4. I am looking for the 5th term now. So let's find out what the 5th term of this whole sequence is. So I go back to this. T to the 5 equals 7c. Okay? My term is the fifth. What does that make my k value? My k value is 4. 1 less than the term always. So I've got 7c4 times a cubed to the 3. Now, oh, I put a 7 there. I think this is a 2. Now I have minus 2 over a to the 4. Okay? So once I know what the term is, I can substitute it into that general term equation to simplify it. Okay? So I go t to the 5 equals. So I've got 7c4 So I've got 35 here, a to the 9 here, and 16 over a to the 4 here. Okay, minus 2 to the power of 4 is 16, a to the 4th on the bottom, equals. Now I take 35 and times it by 16, 560, a to the 9 over a to the 4 is a to the 5. There's the solution. So looking at the question again, it says in the expansion of a cubed minus 2 over a to the power of 7, which term in the simplified form contains a to the 5th? Well, the first thing I had to do was find out what term number it was. So I worked through the pattern using how I would expand this until I got a to the 5th, found out it was the 5th term, then substituted in. My k value is always 1 less than the term. That's how I got 4 there. My n value is the same. It's the same as the exponent. And then a cubed to the 3rd. And the biggest thing is understanding that this is all multiplication. You multiply this through. Lots of people will put subtract signs in because that's a negative there, but it's not. You do your cube, your squared, your power of whatever, 4th. Do that first, and then multiply it all to get to your final answer. And that really covers all that you can possibly see with these questions. Okay? So what I'd like to see you do is get through, well, by Thursday, so today and tomorrow, is finish this one section. And like I said, the perms and coms, you've done lots of questions with them already, but this stuff is new, so I'm going to give you the extra day to do it. Let's finish this up by Thursday. Let's review, and you can review on Friday, and I'll give you that assignment for chapter 11 on Friday for the weekend, and then next week we go back and we start looking at your first few sections. Any questions about any of this right now?
Just once you do it a couple times, and as long as you have your equation, it's pretty straightforward.
Yeah, it's not real tough. It's the initial, like, what for and why that you have to get through, right? So it is just simple expansion, and it doesn't change. There's no way to make it any more difficult than what you just saw there today. Like if you look on page 388, question 7 says find the 6th term, B says find the 10th, C find the 5th, D find the 3rd, and E find the middle term. So that's all there is to it. Just using that equation up there, and you can find all of those terms.
Do you ever have to use like that expanded formula you did before?
No.
It's way faster.
No, you don't have to. And like you don't necessarily need to do it either. It just, you have to understand what the point of this is, and that's the point. We can now expand greater binomials, like to the greater powers, without needing any assistance. without having to stack them. Like before, we would have to stack them and then stack them again and then stack them. Now we can just simply expand it out because there's an actual pattern to all of this. All right. Any other questions or concerns about this course? So let's finish this up for Thursday. Thursday and Friday, we look at the review. Friday, I give you an assignment. All right? Okay.